since. So now the volume came. Hope you enjoy it. It was been silent till now. It's been like a silent film. Yeah, all that non-explanation that happened on the previous stuff. You're welcome. Okay, so you flip these. So you get 1/8, -3, 1/4, -2, 1/2, -1, 1, 0, 0, 1, 4, 2, 8, 3, 16, 4. Okay? So if I sketch the first one, if I sketch the exponential graph, it'd be at -3 1/8, -2 1/4, -1 1/2, 0, 1, 1, 0. This should be 1, 2. 2 to the 1 is 2, not 0. I don't know where I got that from. 1 and 2, 2 and 4. And it looks like this. And my asymptote is here at y equals 0. And it's there because I have no vertical translation, because the vertical translation is the only thing that moves my asymptote, right? What changes my range from being greater than to less than? A reflection in the x-axis. Okay. Now if I draw the other one, it's at 1/8 to -3. 1/4 and -2. 1/2 and -1. 1 and 0. 2 and 1. 4 and 2. So it looks like this. And now I have a vertical asymptote on the y-axis, which is the equation x equals 0. So with exponential, the only thing that moved the asymptote was a vertical translation. And this new graph I drew is a log. And they're inverses of each other because if I drew the line y equals x, which is the identity line, it would reflect perfectly on both sides, correct? So if they're inverses of each other, I can say that the domain of the original is XER. The domain of the exponential is XER. So the range of the log would be YER, because all you're doing is you're changing all the x variables to y variables. So what can you say about the domain of the exponential and the range of the inverse? The same, but x and y, right? So if your range of the original is y is greater than 0, your domain of the inverse is going to be x is greater than 0, right? So if I have an exponential graph and they ask me for the inverse, I can just find the domain and range of those and list the inverses of those. So the x-intercept of the exponential graph will be the y-intercepts of the log, and the y-intercepts of the log graph will be the x-intercepts of the exponential. And they're just vice versa because the zeros switch, right? 0 was in the x, it's now going to be in the y, right? So they completely flip. So what's the only thing that's going to move a log asymptote, a vertical asymptote? Horizontal translation. What will cause my domain, instead of being greater than, to be less than? The reflection in the y-axis. Not equal to. Why'd I put an equal to sign? So they're just inverses of each other, right? Make sense? So you could sketch it down here. I didn't, but we went through it up here. Okay? So then let's flip over to the next page. So increasing exponential. This is just like a little summary of them. An increasing exponential looks like this. Correct? How do I know if an exponential is increasing? Even if it's y equals a b to the actually, I think they label it as c. Anyways, doesn't matter what format it is in. What tells me if it's increasing? My b value. Greater than what? 1. Remember, if my b value is 1, it's just a horizontal line. It's of no help to us, right? 1 to the 0, it'd be a horizontal line at 1. If b is greater than 1, so doubling or tripling, we make doubling b is 2, tripling b is 3. B is a half, what's it doing? It's going down, right? So, I knock that thing out all the time. So if we have this one, b is greater than 1, what's my domain of this? Or, interval notation, negative infinity, positive infinity. What's my range for this one? Is it always greater than? No, it could be less than if there's a reflection in the x-axis. So we'll just do this example. What kind of asymptote do I get? Horizontal or vertical? Horizontal asymptote, and this one in particular is at y equals 0 because the x-axis is y equals 0 and the y-axis is x equals 0. And do I have any x-intercepts in this case? No. Can I have x-intercepts? In a different exponential function, could I have x-intercepts? Yes. If I vertically translate it. So if it's up on top of the x-axis and I vertically translate it down, I'll have x-intercepts. Or if it's below the x-axis and I vertically translate it up, I'll have x-intercepts, right? But just a vertical translation doesn't guarantee x-intercepts, right? If it's above and I move it up, it's just further away from the x-axis. If it's below and I move it down, it's just further away from the x-axis, right? So there's no guarantees. So you can write what you want there. In this case, there are no x-intercepts. I don't really want to write that because then you might come back here and be like, there's never any x-intercepts, but there is, right? And there's always one y. Increasing logarithmic is just the inverse of this. So it goes like this. So my domain is going to be from 0 to infinity. And my range is going to be negative infinity, infinity. And I have a vertical asymptote at x equals 0. So do you see they flip? That's really all that I'm trying to get across here is that your x and y's flip, right? Because they're inverses. Decreasing exponential, b would be between, b is between 0 and 1. B can never be negative. B can never be negative. Your base can never be negative. My domain is negative infinity, positive infinity, and my range is 0 to infinity. And I still have a horizontal asymptote at y equals 0. The increasing and decreasing in this case, because I drew them both very similar with the same asymptotes, nothing changed in those other three columns, right? And the decreasing logarithmic starts here. Okay. So this is conversions between logs and exponential. So with the 30-1, you don't get it on your formula sheet. But you can label them whatever you want, and I'll show you how I would write the formula out for myself. So I always go, they have x equals log b to the n. You can do whatever you want. You could go y equals log bx if you really want to. Whenever I go from log to exponential, I do the 7 rule. So if you put the log on the left, you can make a 7. If you have the log on the right, you're making a reverse 7. So if I wrote this like this, log b to the x equals y. If I want to convert it to exponential, I can go b to the y equals x. B to the y equals x. Another thing to remember is whatever is friends in a log is not going to be friends in an exponential. So right now, b and x are besties. In an exponential, b and x are not besties anymore. Okay? The way I do it, so I don't have to think about even conversions, is the base of your log is the base of your exponent. So the same bases stay. So here's the base of my log. Here's the base of my exponent. They stay the same. And then whatever is friends in one isn't friends in the other. And that's really easy to do them. So if I looked at this one, for example, AB equals C. If I wanted to change that to a log, I would go log base what? Base of my exponent is the base of my log. What's with it right now? B, so what has to be with it? C, and then it equals B. Very, very easy. Base of your exponent, base of your log, and whatever's is friends doesn't stay friends. You can convert them really easily. Okay? So here, you could do 7 rule, 3 to the b equals a, or you can say base of my log is the base of my exponent. What's with it right now? A, so it can't stay with it, so b is exponent, and then it equals a. Right? So for this one, the base of my log is c, so that's going to be the base of my exponent. What's with it is e, so it can't stay with it, right? So d is going to go with it now, and it's going to equal e. Does that make sense? You need to know how to convert between the two. Because now, when we get a word problem that we can't find common base for, we could convert it to a log and solve. Because, why would you want to do that? Well, if you have, don't write this, just pay attention. So say you had 7 equals 1.06 to the x, let's say, right? We had to y1, y2 that to this point, correct? Now what we could do is convert it to a log, because when you convert an exponential to a log, it equals the exponent. And then the exponent would be by itself, and I'd be able to solve it. So base of my exponent becomes the base of my log. So log 1.06. What's with it doesn't stay with it, so the 7 will be with it. And what's it going to equal? The exponent. So whenever you're missing the exponent on an exponential, you can convert it to a log. If and only if there's one exponent. If there was an exponent on this side, we have to do something else. So if both sides had an exponent, variables and exponent, we couldn't just convert it to a log. You can only do it when there's one exponent. Make sense? Okay. So that's why it's important to be able to convert back and forth, because this version would help me. Okay. Express each of these in logarithmic form. Try it out. Okay. So this one, the base of my exponent becomes the base of my log. What's with it doesn't stay with it, so 216 joins it. And then it equals 3. And this is the base. It's like a lowercase number, right? Now, there's two ways to check this to make sure you did it right. Some of you have the log base button. It will make your life easier. Some of you do not have the log base button, but you still need to remember how to do this. So I'm going to show you the way without the log base button. If you want to punch this into your calculator, there is no little base when you press the log button, right? When you press the log button, it's just good like that. So what you can do is you can go like this. So I always draw them like deliberately low down like this, and then I go like this. Shoop, log 6. So punch that into your calculator. Log 216 divided by log 6. And you should get 3 if you convert it correctly. Okay? If you didn't get 3, you probably didn't close a bracket. Make sure you close the bracket behind the 216. Or it's like dividing a log in a log, which is really weird. If you have the TI-83 calculators, this is the only way you're going to be able to do it. If you have the TI-84 calculators and you have the exponent that pops up, you'll probably be able to do it a different way. If you have the exponent that doesn't pop up, you're probably not going to be able to do it a different way. If you have these ones, you'll for sure be able to do it. So some of the TI-84s, it'll be like a little Christmas present, and some of you will not have it. TI-83s don't, for sure. So what you can do is you can go math, and then arrow up to the bottom of the list, and you pick A, which is log base. So math, arrow up, and then it'll pop you to the bottom of the list, and you can pick log base. And it gives you the actual spots to fill it into. But if you have the TI-83s, it won't happen, and some of the TI-84s don't have it as well. They obviously figured it out in some time that it'd be nice, but you still need to know that you can be able to do that, because what they'll do is, Sam solved it some way. He did this. Where did he make an error? And they might do log 6 divided by log 216, and you might not catch it. Remember the error ones, though? You can check if the question only has one variable, you can always check your error questions by step as well. See if this step equals the original step equals the next step equals the next step, and you might find errors that way as well, right? Because if you only have one variable, you could fill a number into it, technically, as long as they tell you b is greater than 1, and you check, does this step equal this step? Does this step equal this step? Does this step equal this step? To check, double check your answer. Always go through and do it correctly, but that's another way to check it. But sometimes steps have more than one answer, or more than one variable, and then you can't do it that way. Unless they give you what the variables stand for, and then you can fill in different numbers for each of the variables. Okay. This one is log base 3, the base of the exponent, of 81, because it wasn't with it, equals 4. This is log base, the base is 2, and then what's not with it is 1/16, because you can't keep what's with it still, and then it equals -4. Oops. And then this one is log base 2x plus 4. And then a goes with it. A is in the same height as log. This base is below it. So log and a are in the same height. This is like a subscript. Equals -1. So the only thing that's below is the base part. Okay? And then we're going to flip over again. Okay, if we converted these, it would be 5 to the 3 equals 125. Because the base of your exponent, base of your log becomes base of your exponent. What's with it doesn't stay with it. And then it equals what's beside. This one, the base of your log is the base of your exponent. What's with it doesn't stay with it. So negative 2 equals 1 over 16. What happened if there would be a 4 in front of here, in front of this log 1000? You'd have to divide it over. You can only convert it if it's plain old log. It can't have a number in front of it. So you'd have to divide the 4 over to the 3/4 and then convert. If you're like, I don't know where to move something, and you're questioning yourself, you're like, I'm not sure where to move it, it's probably because it's not in the right form to move it. So you need to make it into the form you can. So if you're like, I'm not sure what to do with this number in front, we've never dealt with that, then probably have to divide it over, okay? So what is the base if there isn't a base? Nope. 10. Yeah, it's base 10. And unless you've heard that before, you probably are not going to guess 10. So yeah. If the base isn't there, it's base 10. Now, can I show you something else that's interesting? If you take the base and you figure out what exponent gets you this, it also gets you the answer. So if you go 10 to the what is 1,000? 10 to what exponent is 1,000? 3. 5 to what exponent is 125? 3. 4 to what exponent is 16? 2. 4 to what exponent is 1/16? Negative 2. So you can do it that way as well. It's just what it is. Log is log base 10. Ln is log base E. It's just, that's what it is. So whenever you're pressing the log button, it's log base 10. Just like when you press the square root button, it's index of 2. They just made it that way. So if ever you press the square root button, it's an index of 2, assumed. If you want to put any other index in, you have to put it in, right? Log, if it's just a log, it's log base of 10. If you want to put any other log in, you're going to have to use the other log base button. Or you're going to have to do log 1,000 divided by log 10. Yeah, it's just like the square root. Yeah. So this one would be base k to the x equals t. All right. So this one here, a logarithm is always equal to the exponent you need to raise the base to in order to get the other number. Sadly, there's no official name. Complete the following chart to clarify. So if I have log base 2 of 8, I could go log 8 divided by log 2, right? Or I could press the log base button. That's another way. Or I could go 2 to what exponent is 8? 3. So we're actually filling this into the form y equals log base x of, no, 2 of x. We're filling it into this equation. So now I'm filling 4 in for x. So 2 to the what is 4? 2. 2 to what exponent is 2? 1. 2 to what exponent is 1? 2 to what exponent is 2? 1. So 2 to the half is negative 1. It's just negative when it's the fraction, right? And why would that be? Well, we could do this, and I'll show you. You can go log base 2, and what's a half? 2 to the what? Now, when you have base to the base, it always equals the exponent. Now, so if I had log a to the b, it would equal b. Why is that? Because if we have log 2 to the 2 to the negative 1, it's called the power rule of a log. You can take the exponent and you can drop it in front. So this negative 1 can drop in front to here, right? So we'd have negative 1 log base 2 of 2. And what's log base 2 of 2? What is this? It's 1, because it would technically be log 2 divided by log 2, right? So it's just negative 1. So whenever you get this, base to the exponent, your answer is just the exponent. And I would write that down. And the reason why is because of this math here. And this would be negative 2. So this would be 3 to the what is 9. 2. 4 to the what is 16. 4 squared. 5 to the what is 125. 3. 3 to the what is 27. B to the what is 1. 0. Anything to the 0 is 1. B to the what is B? 1. And then log k to the m? M. Make sense? Oh no, it's whoa, whoa! How did that happen? I don't even know. How did that even happen? I dodged it. I was in it for a few seconds. I don't even know how that happened. It might be, but you can't see me, so I don't really care. All right. So I'm going to give you some homework. In the meantime, we're going to finish the rest of this lesson tomorrow.